This is, we're going to be talking about iOS and Swift today. Thanks for coming out. I realize it's 9 a.m. on a Sunday, so thank you so much for you guys coming out so early this morning on a Sunday to listen to Swift and iOS. It's kind of interesting. This is the only iOS talk at Silicon Valley Code Camp. So I was talking to the organizers, and I was like, I don't see an iOS talk on this thing. And they're like, yeah. I go, okay, I got to give one. So this came out of necessity. So I have 45 minutes. I have a hard stop at 9:45. And there's no way I can cover all of Swift and then how to build an iOS app and then iOS best practices in 45 minutes. In fact, I've given classes where I spend an entire day teaching Swift, and we can't get through it. So in 15 minutes, all I can do is give you a sample of what Swift looks like. Now, normally when I teach the class, we go through this language guide. And every single one of these features of Swift is very involved, and it's really powerful. Now, Swift has a dual personality. One, it wants to be a modern language, and two, it has to be backward compatible with Objective-C. The other interesting thing is it has to work in iOS, so it has to be a mobile development language. Now, a lot of people are talking about Swift being used in more places than just iOS, but I want you guys to keep in mind that there is no threading model in Swift, right? Kotlin has threading, Java has threading, a lot of these languages have threading built into it. Swift, what it does is it throws all the threading to Grand Dispatch on iOS. So the operating system controls all of your threading for you. So Swift has no ability for threading. In fact, Swift was built in the open. So you can go into GitHub and see every single submission that's been done for Swift. And there is a proposal for putting threading inside Swift. And if you look at that proposal, it says abandoned. So talking about putting Swift on Linux, it's going to be single-threaded because Swift itself has no native support for threading. So the agenda for today is we're going to do a little bit of discussion on the Swift language by doing a quick tour. When I normally teach the class, we do the full language tutorial. Today, we're doing just a Swift tour. It's going to go pretty fast. When I teach the iOS class at a day-long session, what we do is we go through this starting development iOS apps in Swift. Today, I'm going to also go through all of these steps, but instead of doing it in a day, we're going to do it in 15 minutes. And basically what I'm going to say is, for this section of the project, this is what they're building. And then I'm going to show you in Xcode how that section translates to the code that you write and what it looks like on the actual device. So we're going to talk about building a basic UI, connecting the UI, working with controllers. But I'm going to go very quickly and just give you an overview. So after we've learned Swift and after we've learned how to build an iOS app, we're going to talk about how do you build real-world apps, not hello-world apps. And we're going to do that for 10 minutes. And then we're going to end with the best parts of iOS, because iOS has evolved so much than what we had started with that it's turned into magic. And we're going to talk about the magic of iOS, which is iOS 11, Swift 5 with Xcode 9. So we're going to jump right into the Swift language. And we can sit here and read about Swift and go through it. But what Xcode provides us is an actual something called a playground. And what a playground can do is it can take those pieces of text, and actually run them inside the IDE. So what we see here is this is Swift code. How many people here know Swift? So, okay, so for the people who don't, we're going to run through Swift real quick. Yes, Xcode is the IDE in which you build iOS apps. I'll take all questions at the end, so I can just fly through this real quick. Okay, what we have here is we have Swift code, and the execution of the Swift code is shown on my right-hand side. Now, Swift wants to be a very intuitive programming language to use. So to print hello world, you just write print hello world. It will always put a terminator at the end, a new line, but if you don't want it, you can say, I don't want a terminator at the end of it. The way you do variables in Swift is they can either be immutable, which uses the keyword let, or you can change it by using the keyword var. I disagree with the way they did this. I think it would be a lot better if you don't put anything on the variable. It means it's immutable. You want everything to be immutable. In fact, Xcode will yell at you if you make something a variable, but don't change it. It'll give a warning and say, you really want this to be immutable. And in fact, when you send variables to functions, you don't put a let in front of it because it's implied. So in the future, if they decide to take the keyword let out of declaring variables, it won't break anything in the back end or like the previous versions, but going forward, we won't have to put the word let in there when we mean it's immutable. Now, the variables for Swift are inferred. So as we see here, this is going to be a double, sorry, this is going to be an int, this is going to be a double, or we can tell the variable what type it is by using this type of indicator here, and this is saying you are a type of double. Here we can see we're letting this be a string, and this is a number. When we want to turn that number into a string, in Java, you can just take a string and add it to a number and it'll convert it. But Swift is very strongly typed because Swift wants to be a very safe language, and you have to do the implicit conversion of the int to a string. And we can see the output of these statements here on the right, on my right. Let's see. Also, in the print statement, we have this interpolation, which means it can take a variable and inside the print statement evaluate it. And you can do very, very complex expressions in here. Like here, I'm taking the int of the apple and the int of the orange and doing the square root of them and printing it. So inside print statements, you can do very complex interpolation. You can do multi-line quotes. Swift has two types of data structures. Here we see that we have an array. An array holds a collection of types. And you can have any types in here. You could have strings, doubles, functions, protocols. You can have all sorts of arrays. Anything that's a type, it can hold. But it can only hold one type of that type. So here we see we have strings. I put 500 here. You can't put an int with strings. It has to be a homogeneous type, which is something I really love because there are languages out there that let you throw anything into an array, and when you're pulling stuff out, you just have no idea what you're dealing with. Makes it very unsafe. To get to something in an array, you just use the square brackets. If you want to set it here, we're taking the first element of the array and we're setting it to a water bottle. So those are arrays. The second type, we have dictionaries. Key value pairs, and this is how you do a dictionary where the occupants, their name, and what they do. If you want to add to the dictionary, you just take the key and you put in your type. Again, here we have the key is strings and the type is strings, but you could have anything in this dictionary. You could have your key be a function and your type be a protocol. Any type can be fit into these dictionaries and arrays. Now, if you want to make an empty array, we use this array syntax, which basically says I'm an empty string. This is an empty dictionary. And if you want to clear out a dictionary and array, you just set them to the empty parameters, and that will clear out your dictionary or array. Dictionary arrays are far more powerful than what I just went through. We just don't have in the time of the 15 minutes to go through it any deeper, but they're far more powerful than what I just showed. We're going to touch on flow control really quickly. So here we have an array of ints, and I want to iterate through them. I use for in. And basically what I do is I pass in the array, and the in pops out each int and passes it to score, and I can run that. Now, Swift is a higher order functional programming language, which means it can take a function to a function, have a function inside of it, and return a function. When I program Swift, I'm constantly thinking about how my functional programming works. So here I have this array of ints. I'm going to call the for each on it, pass it a closure, and that closure is going to act on every single element of this array. Whenever you see yourself making a for, stop and think and say, is there a closure I can pass to this array that will act on each point? Because it makes the code much more readable and maintainable. So this for each is much easier to maintain than the for statement. It's been a long time since I wrote a for statement, because I just take my arrays or my dictionaries and I apply a closure to them. Some of the better known closures you can send to your structures are a map, which will take a function and map it to every single element, a filter, which will add a filter to every one of your elements, and a reduce, which will take all of the elements of your array, do some sort of function on them, and return just one value. So you hear a lot about map, filter, and reduce in functional programming. Now, the creator of Alog once said the biggest mistake he ever made, $1 billion mistake, is that he invented allowing a variable to hold a nil. Holding a nil in a variable has caused people, for the last 40 years, has caused billions of dollars of mistakes. Kotlin, Java, Swift, they all circumnavigate this problem by using an optional. And what an optional is you just you say, I have a type of optional string, which means it can hold a nil, or it can hold the variable that you want to assign it to. And what you do is you unwrap the optional. This makes it a much cleaner language. In fact, I've read a lot of Java articles about why you would never want to test for nil. And this gets around us testing for nil. What we do is we have this optional, and we use if let to unwrap the optional. If there's a value in our optional, then we'll use it. If there's not, no harm. We just keep going with our happy path. Now, the only variables that can hold a nil are optionals. If you don't call a variable an optional, you can't give it a variable. If you have an optional and it's nil, you can use the double question marks to give it a value. So here we can see if nickname is nil, then we're going to use the full name. And the double question marks make it a lot easier than having to work with if-lets all over the place. Whoa. Now, here we see a switch statement. And the switch statement is extremely powerful in that the first switch is just switching on a string. The second switch is switching on multiple strings. The third switch is switching on a conditional. So the switch statement in Swift is very powerful. And we have the same thing in Kotlin, that instead of using a switch statement, a case statement, they have when. Very, very powerful, functional, dynamic coding can be done inside of a switch statement or a when statement. And in the full tutorial of this class, we get deep into how powerful the Swift switch statement is. Now, here I want to talk about if you have a data structure which is a dictionary, but the keys of the dictionary are an array, how can you iterate through it? And so here we have the keys are prime, geometry, square, and the elements are an array. So the in statement, what it does is it unpacks both of them at the same time. We don't need to use the keys, so we just use the underscore to say it's not important. We assigned the arrays to this numbers, and then we can go ahead and iterate over the array of numbers in this second for loop. So the in statement can return multiple variables at the same time. Again, I'm just giving a taste of what Swift can do. We have a while statement in Swift, works pretty much the same. Instead of do, we use the keyword repeat. And there is a do statement in Swift, but it's used for scoping. So here I have a variable that is immutable ash equals 7. If I try to actually use that outside of this do loop, it doesn't exist. Do in Swift is used for scoping. And you'll see it around try catches a lot. And I'll give an example of that a little bit later. We have a range operator in Swift. This 0 to 4 says iterate from 0 to 4, but do not include the 4. The one right below it says iterate from 0 to 4, but include the 4. So we use the range operation in a lot of various ways to be able to iterate across a range. Getting deeper into Swift, we have functions and closures. A function is just a named closure. So it's not like functions and closures. Functions are a special case of closures. They're just named closures. I don't have time to get deep into what closures are, but I think of closures as closures are formed, right? Closures are formed because they capture the variables of the outside scope. I'm already at 9:20. I was supposed to finish this at 9:15, so I can't get into the depth of the power of closures. But let's just talk about functions real quick. We have external names and internal names. And Swift 2, 3, 4, all we're playing with, like, how do you get to this external name and this internal name? And now they've settled on, there was this hash marks and all this stuff, but now they settled on, when you write a function, you have the name of the function, you have your external, internal name, type of string, external, internal name, type, and then this is what it's going to return. So this is going to take two strings and return a string. The way I call it is I call the function name, I give the external name, Bob, and then the day. Now, Swift was made for ease of reading. So I don't want to use the first external name because the greet already follows that. So I can just put an underscore, which means don't pay attention to it. So I can say greet John, and for my external name, instead of using day, I'm going to use on. So greet John on Wednesday. So my external name is on, my internal name is day. So when I look inside the function, I use the word day. When I look inside the function, I use the word person, and I don't have an external name on this variable. And you're like, wow, that's a lot of external, internal names just to call functions. It's all for readability, because now I can say, greet John on Wednesday. It makes my life a lot easier, and once you get the hang of function internal, external names, you come to really appreciate the power. So here, we're going to greet Peeps, that's my external name, on Wednesday. Peeps is external, person is internal. I can assign values to my variables on my function by just putting an equals here. So if you don't pass a name in for the first argument, I'll use ash. And Kotlin actually has the same on its functions where you can assign a default variable. Now, Swift, being flexible, allows you to return multiple. Here we see that the return of this function has 3 terms, 3 ints, one called min, max, sum. When I return, I can call those return values by their name. So here I'm getting sum, or I can use the index. Here I'm getting the second index, and I start counting from 0. And that's how we return. You can have functions inside of functions. So this return 15 takes no arguments, has an internal function that it takes the 10 plus y, and it just returns. So functions can have functions inside of them. Now this is a higher order language, a functional language, so I can return a function. So here we see I take an int, and I return a function. When I call make increment by 1, this is now a function I can call. So I can pass this an increment by 1, and I'll get 8. Or I can call this make increment by 2. This number comes into by here. It's setting this variable. So when I pass in 7, I get 9, because this is returning a function that I can pass it into, and it will increment it by whatever number I passed in and pass back. So when I write in Kotlin, I do all my work in Kotlin at work, I think about how I use functions. And I do scientific programming. We had various mass specs. And each mass spec had a different type of analysis it would do on the data. The person who had the code before me wrote all of this code for all these different mass specs. But I realized all I have to do is change the internal function of how it analyzes this data. I was able to write just one object, and then I would send in the function that it needs to do on that. So that one object, whatever mass spec you want, I just figured out what function I want to pass into it. Just like here, I'm generating different functions depending on what I need them to do. So thinking of higher order functional programming languages makes the code far simpler to maintain and actually just all interactions with it. Here, what we see is we're going to take an array of ints, and we're going to pass in a function, and we're going to return a bool. Depending on the function I pass in, this object will be doing different things. So here I'm passing in a function that will tell me if this array is less than 10. I pass in this function, and I pass in my array, and I get it's true. But if I turn this into 17, what happens is it turns false, because the function I'm passing into this function is calculating the array that I'm passing into it, and it's returning that false. Now, if you have an array and you're doing an operation on that array, and you're sending in a closure, Swift has ways to make that closure much more readable. So if we look at this, we have a map, and we're passing this closure in. But Swift can infer that it's a return, can infer that we're multiplying by 3, so we can get rid of that let. It can infer that it's being returned, so we can get rid of the return. It can infer the type, so we can get rid of the ints. It knows that it's a closure, so we can get rid of this in. And we're left with something that, and then we know that the terms we're setting in are $0, $1, $2, $3, so we can get rid of the variable number. And we're left with something that's very concise. Whatever you pass me in, I'm going to multiply by 3, and I'm going to map it to every single element in your array. And in fact, that's what's happening here, that we can see every element is being multiplied by 3. And this kind of very clean syntax, you'll see a lot of people in Swift doing this. So again, the sort method, the map method, the filter method, and the reduce method, you're going to see very clean arguments inside closures being sent to these various closures. And again, here, this is very easy to read. The first thing you pass into me should be greater than the second. I'm going to pass that in to the sort of my array, and I'm going to get a sorted list back. I realize I'm going fast, but I'm already should be done with this section, but we're just trying to get through this. Now, we have classes, and a class is made up of properties and functions, and they must be fully initialized. So when you build a class, you notice I'm putting the number of sides here to 0. So everything, when I use this class, is fully initialized. To instantiate the class, I just use these parentheses, and I can set its properties and call its methods. Here, we see that string is not initialized, so I have to have an initializer on this class. If this was a struct, I would not need this initializer. I would have a convenience initializer built for me if I had this as a struct. The difference between structures and classes in Swift is that classes are sent by reference and structs are copied. When you're working in Swift, you'll see a lot of the iOS and Objective-C coupling is done in structs. So iOS has a lot of structs in it. Getting back to classes, what we see here is I need to initialize my number of sides, and I need to pass in my name for the square. So here I'm calling my class and calling that. So getting deeper into it, we see that when I want to make this square, all right, it's setting the number of sides, and then I can call my description, right? Let's see. Because I'm doing inheritance on this named shape, I'm inheriting all of its methods, but I can override any of my superclass methods by just using this override keyword. Now, when you're working in Swift, we also have protocols. This could be a protocol or it could be a class. And the way you want to figure out, if you hold down the Option key and you click on it, it'll tell you if it's a protocol or a class. And we're going to get deeper into protocols and classes in a little bit. We also have something in Swift called computed properties. This property parameter is not being initialized, but it doesn't have to be, because every time we get it and we set it, we're multiplying it by a constant and using this variable. So this is really powerful in iOS development in the fact that these computed properties allow us, when we're using our IB outlets or working in iOS, we have a chance before we use the variable and after we use when we're getting and we're setting it, we're able to compute it. Not only can we have computer properties, but we can call will set and did set on our properties, which means before you use it, I want you to take the value that you're going to be using, which is now encapsulated in this new value, and I want you to do some computation for me. And on did set, we actually have something called old value that we can use. So with will set and did set, it gives us greater power to work with our properties. And we're almost done. We're going to talk about enums and structures. Enums are very, very powerful in the fact that they can have full functions inside the enum. So here we see that we have a rank, and we're going to set the rank to ace, which sets that rank for us. And now when we call a simple description, it executes the case for the ace and returns ace when we print it. In the previous example, we had raw types in our enums by just setting the very first case to the raw type we want, but you don't have to have raw types in your enums. We also have structures in Swift. Structures are passed by value, where classes are passed by reference. And a structure, you don't have to have everything initialized. You have to have everything initialized, but you don't have to have a init method because you get a convenience init method. Like here, we don't have rank and suit set, but we can still call the convenience initializer and set them. Now, Swift is a protocol-based language. So all a protocol is a function, signature, and variables. And if you say, I support this protocol, then you're signing a contract to say, I have that variable, and I also support that function. So here we have an example protocol. And we see that simple class has example protocol. So we have this variable that it sets, and we have adjust. When we do iOS programming, our buttons and our labels, they all adhere to certain protocols. So Swift is a very protocol enhanced language. So when we have a protocol, and so if we have a structure and it's using a protocol, and it has a function, and that function is changing something inside that structure, we have to say it's mutating. And I'll get deeper into this when we get into Xcode. One of the beautiful things about Swift is we have extensions. Extensions are a way to extend a class when we don't have access to the code. So here, I'm going to put an extension on int. Int is a library I don't have access to. So I'm going to put an extension on it, which is, I'm going to adjust it by 42. So if I just take this int, which is 7, I can call simple description on it, which is a part of my extension, and I can call adjust on it, which would add 42 on it. So you can think of all of the libraries out there that you want to be able to extend to, right? You can use this mechanism and inherit from a protocol, or have different functions that you can add to your various libraries, even knowing you don't have the source code. So Swift has only one level of inheritance, but you can have as many protocols on the structure class as you want. So it's a single inheritance. Swift also has error handling. The way you do that is you you conform to the protocol error, and anything that conforms to the protocol error can be thrown. Send is going to throw, and the way you do that is you just use the throw keyword. Because this adheres to the protocol, this throw knows how to throw it. And I did it with an enum up here, and I did it with a struct. So you can see, this returns a string, or it can throw. This returns an int, or it can throw. And so that's how you would throw. Now, in the code, you would do a do, and then you would try. If that try fails, the catch would run. So here, if send does not work, this catch statement would be caught. If send num doesn't work, this catch statement would be caught, because I had a struct in the enum that were both throwing. Again, some more try catch. A better way to do it, instead of doing what you do is you just say try conditionally, and if the try works, then the variable is set. If the try doesn't work, it's set to nil. You see this, it's a much cleaner. Let's see here. Okay. Okay, generics are very, very powerful. Now, what this function does is it takes anything, any type you can get, and it will make an array of those, of the number of you pass in. So here, we're passing in a string, and we make 4 of them. Here, we're passing an int, and we're making 12 of those. Here, we're passing in a protocol. We're making an array of protocols, right? Because a type, this array can take any type. Protocol is just a type. A function is just a type. What I'm doing here is I am taking this function and putting it into this generic array, right? So this array held strings, ints, protocols. Now it's holding a function. I'm making 7 of these, and I'm passing it to answer. And then on answer, I'm printing those functions. And here, I'm not printing those functions. I'm executing those functions and printing their results. So generics are really powerful because you can just pass in a set of functions and then just execute them right out of that array. Again, here we see anything that has the protocol equitable in it, we can pass into this generic. And any type, we could, if the function has equitable, if the protocol, if the int, if the string, I can pass in 2 different generic arrays in here, and it will tell me if it has an element that's the same. Again, generics are really, really powerful. And that, we are done with Swift. That gives me 5 minutes to go through Xcode, which I apologize, I really thought this was going to go faster. So normally what I do is I take people through how to build an iOS app by going through this series of steps. We start with building the UI, connecting the code, working with controllers, implementing a custom view, building a data model. Now, almost all applications have a table view. This is This table view is similar to the recycler view you get in Android. Anytime you make a list, you're going to be using these table views. How to build navigation, and then adding behaviors, and then persistence. So if we look at our Xcode, sorry. Okay. Okay. So if we look at Xcode, I have this up. Okay. When you go through this section, building the UI, they're basically going to show you how to build a graphical user interface inside storyboards, right? So they're going to basically show you how to do this. Quick tour of Xcode. This is where you find the files. This is source control. This is your hierarchy viewer. When you want to test your app, you can choose from various devices to simulate on. If you want to search for something, this really powerful search tool searches all your code. Any messages would come up here. This is where you run your test cases. This is for the debugger. This is your breakpoints. Any messages you have when you build or compile go here. These are your files. Your Swift files will show up on this side. And if we were to start building, this app delegate is the main beginning part of the program. Now, when you first start off building your UI, you're going to go into this piece of code, and they're going to ask you to bring up a storyboard. This storyboard is made out of various views. You get the components for these views from your components list here. So you can find your views here, your buttons, your table views, all of this. You can find snippets of code down here to use. Also, any assets. So when you want to build an iOS app, what they do is they start you off in the storyboard. And the storyboard, you pull components off of this panel here and onto your views. So here I'm working with an iPhone X, and I'm putting my views down here. If I wanted to get information about my views, I have this hierarchy of my components. I can see that this meal scene is made out of this meal, which contains this table, this prototype cell, made from photos, labels, controls. And I got all of this from my panel over here. If I need more information about my various components, I can get information from the file viewer. This is quick help. This is the identity inspector. And basically, what happens is when I need to get more information about how this component is put together, I look at my identity inspector. This is the attributes of that component: its width, its size, its color. Here, I put in my all of my sizing information. And this one shows me my connections. So what we're going to do in this part is you're going to connect the UI to the code. And the way you do that is we have this scene here, and we want to be able to control it. So if I go over here and I click this little button, and I go to my my identity inspector, I see this. This is the class that is controlling this UI. And the way I build that is I come over here to my code, I write the Swift, and then I choose this and I link them. Now that they're linked, you'll notice that I have these IB outlets. If I hover over an IB outlet, you'll notice it'll show me how it's connected to the code, right? So this outlet is up here on the name. This one is on the photo. This is on the stars. This is on the save button. I have now linked my code to my UI. Android does this with the R file. So if you have your XML in your Android and you want to find by ID, this is the same thing, except in iOS you control drag, and in Android you use the XML file. Now that I've linked my code to my UI, I want to be able to perform actions on it. So that's what the IB outlets allow me to set my UI, and my IB actions allow me to react to button clicks. In the last few minutes, I want to talk about navigation. So we see here, we have a whole bunch of different scenes in our Xcode that we need to navigate through. Okay, sorry, I should talk about these buttons real quick. This one closes the editor, this one closes the debugger, and this closes your component side panel. But we actually want to look at this real quick. The way you navigate from scene to scene is you control drag from one scene to another, and it builds segues. So if we were to look at this button here, it's a plus button. And what that plus button does is it brings up a modal scene. And right here we see the word modal. Modal means I'm going to take over the entire screen. This is the app running. If I bring up this plus button, he's going to bring up the whole scene. The only way I can get out is by hitting this cancel button, and it takes it away. This is very different than if I use navigation. Navigation gives me a back button. So here, what we see is I am navigating through this navigation controller, and this is hooked up to the plus button on the main screen. So if I go back to my simulator and I click this plus button, no, that's modal. It's hooked up to this. You notice I'm navigating now, right? So if I click on one of the rows, I'm navigating over, and it's not modal. It's not coming up from the bottom. So when you are looking at your storyboard, if you see a navigation controller, you're navigating. If you're looking at something that is modal, you're popping it up. Now, if you want to unwind your segue, this save button, if we look at it, it has an unwind on it. It has an unwind on it, which basically tells us that what they did is they went from this save button to this exit, which is going to unwind the segue. And the unwind segue actually goes to the first view. So this save unwinds, and you see it highlights the view it's going to. So this save uses this exit to unwind to this view. One of the last things I want to say real quick, because we're kind of out of time. First, I apologize for not getting farther. It's just a lot to cover. You can put gestures on your scenes. And the way you do that is you come down here and there's various gestures that you can put on. You just grab a gesture, like here we have this pinch gesture or whatever, and you just drop it on what you want to drop it onto. Here we have a touch gesture that was placed on the photo. And if I look at the photo, what I'll notice is there's this tap gesture that's highlighting this button. So I basically said, when I dropped the tap gesture on this photo, this box appeared. And I can drag this box to my source code for what I want to happen in my source code when that touch gesture happens. So I can now put gestures on it, and I can link the gestures to the code. Now, this view controller is hooked up to this piece of code, this view controller, and I can actually go on that, and when I highlight this, it actually shows me to the piece of code that's going to be running. Kind of an overview of iOS. I just wanted to touch on one last thing. There are slides up on my talk that go through iOS best practices, and I hope you get a chance to look through those real quick. They go through what's special about the hardware, what's special about the software, learning it. I go through all the best resources for Apple on how to learn iOS. The Stanford latest class, which is iOS 10 and Swift 3. Udacity classes, which are totally free, get you up to speed. Coursera, CodePath has amazing cheat notes, cliff notes for anything you want to do on iOS. If you want to work with, say, a piece of UI or something, they have cliff notes on how to do it. It goes through mobile development. I talk about what you should really know before you start, how to get engaged in the community, the best coding standards to use, how we design UI, tools. I go through source control, project management, how to think about your user and the best way to build for the user. It's called data-driven ethnography. And if you want to learn more about it, I have some links here on the bottom. If this would get out of the way. Yeah, so there's links on the bottom here that take you to the Stanford class so you can learn about design thinking. Stanford CS 147 and 247. I talk about the best libraries. Dependency management, right now we start with CocoaPods, then we learned Carthage, and now we're using the Swift Package Manager. These library resources are so amazing. If you're writing code, you're arrogant. If I'm writing code, I'm arrogant. Anything we want to do, it's in one of these libraries. And when you go to the GitHub page, they have animations to show you what the UI is going to look like before you even download it into your projects. So you have a really clear idea of what these libraries are doing. These libraries cover every aspect of iOS development. I go into hackathons, I can win $40,000 in a weekend because I just take these libraries, I snap it together. I can build at the speed of thought. These libraries are amazing. Please use them. Some of the libraries I always use: RX Swift, Realm, Quick, Dependency Injector, Instruments, Crashalytics, and then I always check my distribution and analytics to get user reports. Apple has amazing kits for us: Health Kit, Home Kit, Car Kit, Play Kit, Game Kit, Map Kit, Watch Kit, Cloud Kit. Please look into them. It's amazing, amazing resources. I used to do a lot of back-end work. I do no back-end work anymore. I used to use Parse, now I use Firebase. Firebase allows me to do notification messaging. I have pumped billions of messages on Firebase for free. Firebase is amazing. If you're using a backend, I really encourage you to start looking into Firebase. This is code and blogs from various companies. Square and Twitter, LinkedIn and Netflix, they're talking about how to build iOS, best practices, how they do it, tools that they use. Uber and Lyft, their code, their engineering blogs. If you're looking for a job, read these engineering blogs, because inside the engineering blogs, they have links to job offers, because they're like, man, if you're going through our engineering blogs and using our code, we want to hire you. Airbnb, Foursquare, Yelp, and then analytics are very important, because when people show me stuff, I say, look, in God I trust, everybody else, bring me your data. I don't believe what you're saying until I can see your data. So data is very important. I have some links for analytics. And then distribution and monetization. There is a site called Think with Google, right? Think with Google. Google has spent billions of dollars trying to figure out how to do monetization and drive distribution. They have put all of that up online for us to to understand how to monetize our apps. So it's think with Google. You can get consumer insights, marketing resources, advertising, lots and lots of data and analysis of why would someone download your app and how would you monetize that. Billions of dollars worth of research. I highly encourage you guys to follow Think with Google. The website doesn't even have google.com in it, but Think with Google is a Google organization. And with that, I am way over. I apologize. Next time I'll try to get through everything a lot faster. I'm up here for questions if you have anything. Thank you, guys.